So hello friends, today in this video we will talk about the physical properties of alkanes. So now start. Alkanes are generally alkanes are generally odorless and colorless. Alkanes are generally odorless and colorless, but there is an exception. Ethene ethene is ethene have a pleasant smell. Ethene has a pleasant smell, but it is also colorless. Ethane have a pleasant smell, but it is also colorless. And the most important property of the alkane is that there is weak van der Waals force between the atoms of the compound. Weak van der Waals forces between the atom of the molecules or compounds. And from this property and another property derives, which is first first four members of first four members of alkane first four members of alkane first four members of alkane are in are exist in gaseous state. And from pentane till 17 carbon containing 17 carbon containing molecules exist in liquid state. And some other properties are, if the size increases molecular molecular size increases then the boiling point increases then the boiling point also increases. If the molecular size of the alkane increases, then the boiling point of that compound is also increases. The reason behind is that if the molecular size increases, then the van der Waals force is also increases. Van der Waals force also increases also increases with the increase in with the increase in molecular size. So as we already know, if there will be the powerful or strong bond between the atoms, then it's very hard to break the bond. So we have to give the more heat or in energy to break that bond between the atoms. So if the molecular size increases, then the van der Waals force increases between the atom, so the boiling point increases. Okay, now another property, state chain state chain of alkanes have Straight chains alkanes have higher boiling point in compared to branched alkanes. The reason behind is that if the branched increase in a molecule, then the shape of the molecule goes towards a spherical shape, and if there is no chain in the molecule, so that will be in a straight chain. If the branched branched increases, then the shape of the molecule is like C. I am not writing here the hydrogen, so C C C C C C C C C. It is almost spherical. So the van der Waals forces between the atoms decreases. Like this is one compound, and this is uh, one molecule. This is one molecule, and this is the another molecule. So there is less van der Waals force between them, because it's more towards the spherical shape, and the straight chains, they always remains straight, so they will have more boiling point compared to the these branched alkanes. There is the van der Waals force greater in comparison to the these branched alkanes, so its boiling point will be more in the compared to the these branched alkanes. And alkanes are generally soluble in alkanes are generally soluble in non-polar solvents. And now chemical properties of the alkanes. Chemical properties chemical properties of alkanes. First is halogenation. Halogenation. This halogenation word is composed of two words. First is halo and second is genation. Halo, as we are very familiar with halo group. Halo group is fluorine, chlorine, bromine and iodine. These are the members of the halo group. And genation means addition. So what's this word means? Addition of halogen addition of halogen atoms in alkanes. Here hydrogen atom is hydrogen atom is replaced by the any halogen of these four, from the halogens. So we will take a example of that. First example, like firstly we take CH4 plus Cl2 in the presence of UV rays. So it will form CH3Cl plus HCl. And now again we will perform the halogenation process in this compound. So CH3Cl plus Cl2, it will give CH2Cl2 plus HCl. Now we will again perform halogenation process in this compound. So in CS2Cl, CS2Cl2 plus Cl2 in the presence of UV rays, it will give CHCl3 plus HCl. Now again, so CHCl3 plus Cl2 in the presence of UV rays, so it will give CH, no, H, all the H will be replaced. CCl4, carbon, this is carbon tetrachloride, carbon tetrachloride, CHLORIDE. This is carbon tetrachloride. Here one carbon atom is present and four. For four chlorine atoms, the tetra word is used here, plus HCl. So this was the first chemical properties of the alkanes. That was halogenation. So in the halogenation, we add halogens atoms in the presence of UV rays in the alkanes. Now the now the some more things in this. The iodination, the chlorination was performed in the presence of UV rays, but the bromination is very slow process. Bromination, very slow process as we can say. And the iodination, iodine, iodination. Iodination is very slow. It is it is very slow. It is very slow and almost a reversible process. Almost a reversible process or reversible reaction. As we are very familiar with reversible reactions, the reactions in which the product is have potential to convert in the form of reactants. So CH4 plus I2, we show it with two arrows, half-headed arrows. With this is the sign of reversible reaction. It will form CH3I plus HI. So we use oxidizing agent here to perform this reaction in forward direction. We use oxidizing agent. This is oxidizing agent to perform this reaction, to perform this reaction in forward direction, in forward direction. And as we all know that the fluorine is very highly reactive element. So the fluorination process is the process fluorination process is too violent. Fluorination process is too violent to be controlled. To be controlled. So we dilute it with the nitrogen. We dilute fluorine with the nitrogen to control this reaction. So before fluorination, we we dilute it with nitrogen. And the rate of the rate of replacement of hydrogen, the rate of replacement of hydrogen of alkanes by halogens, is 3 degree greater than 2 degree greater than 1 degree. What is this 3 degree, 2 degree and 1 degree? 3 degree is the tertiary carbon, the hydrogen atom attached to the tertiary carbon. What is tertiary carbon? The carbon which is directly attached to the three more carbons. What is secondary carbon? The carbon which is directly attached to the two more carbon atoms. And what is primary carbon or 1 degree carbon? The carbon which is directly attached to the only and only one carbon atom. So that is the primary carbon atom. So the rate of replacement of hydrogen of alkanes by halogens is 3 degree, then 2 degree, then 1 degree. And the next chemical properties of alkanes is combustion. As we already know, the combustion means burning of anything in the presence of oxygen. So alkanes plus O2 gives CO2 plus H2O. There is a general equation for this. I am going to write here CnH2n plus 2. This is the general formula of alkane. Alkane plus 3n plus 1 by 2 moles of O2 gives n moles of CO2 plus n plus 1 moles of H2O. And there is an incomplete combustion process. Incomplete combustion. From this process, we prepare carbon black. During this process, the insufficient amount of O2 or air is react with alkane. So we insufficient amount of oxygen or air react with alkane, so we gain carbon black. I am going to write a equation here, reaction. So CH4 in the gaseous state plus O2 gaseous state, there should be an incomplete combustion. So it will form carbon black in the form of solid plus H2O in the form of liquid state. And third one is controlled oxidation. And this incomplete combustion is uh, only done for the preparation of carbon black, which is used in the manufacture of ink, printer ink, black pigments as a filters. So for the preparation of printer ink, we prepare carbon black from the process of incomplete combustion. So now the next process is controlled oxidation. Okay. Alkanes on heating with a regulated supply of dioxygen. We give the only that amount of oxygen that in amount the process is required. So there are three reactions. We can form alcohols, we can form aldehyde, we can form acids from this controlled oxidation. First is for preparation of alcohols. We have to give the special or specialized catalyst, specialized temperature and specialized pressure for the preparation of alcohol, aldehyde and carboxylic acids. So for the preparation of alcohols we have to use copper catalyst, and we have to give the heat of amount 523 degree Kelvin and the pressure of 100 atm. So it will give 2CS3OH. This is a alcohol. For the preparation of aldehyde, we also take an alkane, and in the presence of oxygen, in the presence of an special catalyst which is MO2O3, and it will form an aldehyde group plus with water. And the next is there will be two molecules of ethane plus 3 moles of O2 in the presence of CS3COO whole twice Mn. On heating it, we will obtain 2CS3 2CS3COOH plus 2S2O. And the next chemical properties of alkanes is isomerization. This next property is isomerization. As we already know that what are the isomers. The isomers means the chemical formula is same. Chemical formula is same of the compounds, but their orientation is different. Its mean is that their chemical formula will be same, but the there will be the different in the position of the alkyl group, double bond. These will be the isomers. So we heat an alkane. An alkane means straight chain alkanes in the presence of anhydrous aluminum chloride and hydrogen chloride gas. We heat an alkane in the presence of AlCl3, anhydrous AlCl3 and HCl to form isomers. And this process is known as isomerization. So when we heat the N-alkanes in the presence of anhydrous AlCl3, aluminum chloride and HCl, hydrogen chloride. So we form the isomers of that taken alkane in the form of branched alkanes or any bronze alkanes isomers. So let us see the an example. We take CH3 CH2, add CS3 in the presence of anhydrous AlCl3 and HCl. So we will get CS3 CH and CH2. CS3CH attached with CS2 whole twice, and here one alkyl group is present. And the next process is aromatization. Process of converting. What is aromatization? Process of converting aliphatic and alicyclic. Process of converting aliphatic and alicyclic hydrocarbons hydrocarbons to aromatic hydrocarbons. Aromatic hydrocarbons. What are aromatic hydrocarbons? So we will discuss in the next video. What are aromatic hydrocarbons? In presence of in presence of suitable catalyst suitable catalyst at high pressure at high pressure and temperature. So we will take a aliphatic compound CS3 CS2 CS2 CH2 CS2 CS3. The IUPAC nomenclature of this compound will be 1, 2, 3, 4, 5, 6. This compound contains 6 carbons. So the root word will be used for this compound is hex, and there are only and only single bonds between the all atoms. So N will be used as a prefix in this compound. So the nomenclature is hex N. In the presence of, we can use any catalyst from these V2O5 or MO2 molybdenum oxide, and the temperature is 773 Kelvin and the pressure is 10 to 20 atm. So it will be convert into an aromatic compound. This is a very famous aromatic compound which is benzene. This is an benzene. We can also see it as uh, these both are the canonical structures of each other, and its hybrid structure is this dotted circle represent the delocalized pi electrons. So now we will saw some we will see some another properties of we will see the properties of methane here. Methane reacts with steam. Methane means CH4. CH4 reacts with steam. Methane reacts with steam in the presence of nickel catalyst and at the temperature of 1273 degree Kelvin. So we will get carbon monoxide and hydrogen. So for the preparation of carbon monoxide, this is the process which is used in the industries. This is the industrial preparation of dihydrogen gas. And here this process is generally used for the preparation of dihydrogen gas. And thank you for watching this video.